Okay, guys, so quick review on solving linear systems, which obviously you learned about in Algebra 1, and we review it because it's a very important skill, okay, going forward with pre-calc, and if you guys come back to calc, it's incredibly important tool. Okay, so when we're solving a system, okay, we're looking for the coordinates of points of intersection. Okay, so if we're solving a linear system, obviously there's only one point. Two lines intersect to form one point. Okay, but clearly you could have systems involving quadratics where you could get multiple points of intersection. Okay, but we're just dealing with linear systems, so it's just one point we're looking for. Okay, so as you learned back in Algebra 1, and hopefully you had a chance to do some of this in Algebra 2 as well, okay, we have two different methods for solving a linear system. The first one is substitution. Okay, so in substitution, we want to isolate a variable. Doesn't matter x or y. Okay, isolate a variable in one equation and then substitute it into the other equation so that we create, okay, one equation with only one variable in it. Okay, so when you're doing it by substitution, I would take a look at the two equations to begin with and ask yourself, what would be the easiest variable to isolate? Now, it doesn't matter which one you isolate. You could isolate x or isolate y, and you could do that in either of the two equations. It makes no difference, okay? But we're trying to make things or streamline things. So that's what I asked myself. What would be the easiest thing to isolate in these two equations? And clearly isolating y in the first one would be the easiest because it has a coefficient of -1. Okay, so anytime you have one of the terms that has a coefficient of 1 or -1, those guys are always easy to isolate. So you figure right here, if I just take that 2x and move it to the other side, it becomes -2x. So I get -y equals -2x minus 7. And then I divide everything by -1, so I get y equals a positive 2x plus 7. So that means I can substitute 2x plus 7 in for y in the other equation. Okay, so I have my -3 times y, which is 2x plus 7. Okay, plus the 5x equals 1. And notice I have an equation in one variable, so I can solve for x. And whatever I get here ends up being the x coordinate of my point of intersection. Okay, so this is going back to Algebra 1. Distribute the -3, so I get a -6x minus 21 plus 5x equals 1. Collect similar terms, so I get a -x minus 21 equals 1. And then add 21 to both sides, so I get -x equals 22, and then divide both sides by -1, so I get x equals a -22. Okay, so my x coordinate of my solution, okay, is -22. Okay, all right, so what we'd want to do, I got to generate my y coordinate, so I would want to take this x equals -22 and substitute it back into either one of these equations, okay, to come up with my y coordinate. So I'll just take, I'm going to take the first one. I'm going to use that guy. So I get 2 times -22 minus y equals -7. So that gives me a -44 minus y equals -7. And adding 44 to both sides, I get -y equals a positive 37. So that means y equals -37. Okay, so that would be a -37. Okay, now I would certainly, if you have time, we want to check, make sure that this solution works in both of them. Okay, so if I go 2 times -22 minus a -37, does that equal -7? Okay, so I have a negative 44 plus 37 equals negative 7, and that works out. Okay, so that one works. So check the other ones. We have negative 3 times negative 22 plus 5 times negative 37. Does that equal 1? Okay, so let's see. When I multiply these guys together, okay, I'm going to get a positive, what is that, a positive 66? Something here isn't working out. I don't like this guy. Okay, this is a positive 66. Oh, that's why. I got the x and y mixed up. Okay, that's negative 3y. Okay, notice how easy it was to make that mistake. Okay, that's a negative 3y, so the negative 37 should go here. Okay, and that's a 5x, so the negative 22 should go here. Notice how easy it was to make that mistake. Okay, so this would be a positive, I think I know what it is. 3 times 37, that's a positive 111. And this would be a negative 110 equals 1, and clearly that works out. So we should feel good about this solution. And in good shape there. Okay, let's try a couple more of these guys. All right, let's see. Now we'll do number 1. Okay, so notice that clearly it's going to be easier to isolate the x right here in the second one. All I'd have to do is take this negative 2y and move it over so it becomes positive 2y. So I get x equals 2y minus 3, and then I take that and I substitute 2y minus 3 in for x up here. So I get 5 times 2y minus 3 minus the 4y equals 9. Okay, and just solve for y. So I get 10y minus 15 minus 4y equals 9. Add the 10y and the negative 4y, so I get 6y minus 15 equals 9. Adding 15 to both sides, I get 6y equals 24, so y obviously is 4. Okay, so in my solution, I know that my y coordinate has to be 4. Okay, so you say, okay, let's go back and evaluate. And I think this second one will probably be the easiest guy to evaluate. So we take x minus 2 times y, which is 4, equals negative 3. So I get x minus 8 equals negative 3, and adding 8 to both sides, we're going to get x equal to 5. So our x coordinate is 5. And then you could go check, okay, if you have time. Sometimes we do, sometimes we don't. So I go 5 times x, which is 5, minus 4 times y, which is 4. Does that equal 9? Well, that's 25 minus 16, and indeed that gives us 9. And then check the second one. Okay, so I get 5 minus 2 times y, which is 4. Does that equal negative 3? Well, I'd have 5 minus 8, and that certainly is negative 3. So we should feel good about our solution there. Okay, we'll do one more of them. Okay, and I'll do number 3 because that guy looks a little bit different than these guys. And if you want to do that one on your own, you're more than welcome to. Okay, it's up to you. All right, now, this guy right here, notice how both of them are in slope-intercept form. Y equals mx plus b. Y equals mx plus b, because that would be just a plus 0. Okay, so if this guy is equal to y and that guy is equal to y, wouldn't these two guys have to be equal to each other? Okay, by substitution. Okay, so yeah, so this one's even easier because you don't have to isolate a variable because y is already isolated for you. So we get 1/2 x minus 9 equals 3/4 x. And we got to solve that. So if I subtract 1/2 x from both sides, that will give me 1/4 x equals negative 9. And then I could divide both sides by 1/4 or multiply both sides by 4. Either way, I'm going to get x equals negative 36. So in my solution, Okay, I know my x coordinate is negative 36. Okay, now I got to find my y coordinate. So you could substitute in either one. I'll do it with this guy right here. So I say y equals 3/4 times x, which is negative 36. Okay, and so y ends up being, let's see, that's a negative. 36 divided by 4 is 9. 9 times 3 is 27, so I get negative 27. Okay, and obviously you could go back and check that. Okay, if I put negative 36 in here, okay, I'd get negative 18 minus 9, which is negative 27. Good. Okay, and if I put negative 36 in here, I get negative 27. So yeah, it works out. So we're in good shape. Okay, and like I said, if you guys want to do that one for more practice, it's just like this one. Okay, you guys go ahead and knock yourself out. Okay, all right, then we have solving by elimination. Okay, now, when we solve by elimination, okay, we've got to eliminate one of the two variables. Okay, now to be able to do this, okay, we need both of these equations in standard form. Okay, now standard form, and this is going back to Algebra 1, Algebra 2. Standard form, ax plus by equals c, okay, where a, b, and c are all integers. Okay, so you can't have any decimals or fractions in there. Okay, all your numbers have to be integers. Okay, and notice you always have it where the term with x and the term with y are on one side, and a constant is on the other side. So the very first thing I do is put them all in standard form. Okay, these two are pretty easy to do because notice we don't have any decimals or fractions to begin with. Okay, now standard form is something that you start seeing on a regular basis in higher math. Usually, okay, in Algebra 1, all you see is slope-intercept form. Okay, so you get, y equals mx plus b, where m is your slope and b is your y-intercept. But the higher you go in math, the more you start seeing this standard form. Okay, and so the very first thing I would do is if I had any fractions or decimals, I'd get rid of them. Okay, but notice I don't. So really, this guy right here, all I got to do is just take that negative 3x and move it over to the left-hand side. Okay, so I'd get 3x plus y equals negative 11. And then this guy, same thing. All I got to do is take that negative x and move it over to the other side, change its sign. So I'd get a positive x plus 5y equals 2. And so I get this system right here. Now, what I want to do is I want to add these two together. And in doing so, I want to cause one of the variables to disappear. Okay, so I've got two choices here. Notice I could take the top one and multiply by negative 5, because that'll make this a negative 5y. And when I add down negative 5y plus 5y is 0, and the y's go away. Okay, or I could take the bottom one, if I wanted to, and I could multiply the bottom one, okay, by negative 3. And in doing so, that'll give me a negative 3x. And then when I add 3x plus negative 3x is 0, and the x's go away. I'm going to do it this way, okay? So I'm not going to do anything to the first guy. Leave him alone. 3x plus y equals negative 11. And then multiply everything in the second one by negative 3. So that'll give me a negative 3x, a negative 15y, okay, and a negative 6. And then I add straight down. Okay, so the x's go away, and notice I get a negative 14y equals negative 17. And when I divide through, I get y equals a positive 17/14. Okay, so my solution, and I'm glad we finally have one where we get a fraction because that happens all the time. My y coordinate is 17/14. Okay, and so I gotta go back and I gotta find my x coordinate, so I would probably go here in this second one, okay? And bring that second one over. And so we get 5y equals the opposite of 17/14, okay, plus 2. So I get 5y equals. Okay, let's see. I know I can do that in my head, but some of you might not be able to. So we get the opposite of 17/14 plus 2, and we get 11/14. And then I divide both sides by 5, so I'm going to get y equals 11/70. I'm pretty sure. Okay, if I take that and divide by 5, yeah, 11/70 is. So that is my, y. Wait a minute, this is my y here. Oh, I made a mistake there, didn't I? Okay, so let's go back and let's fix this. I like when I make mistakes because then I can show you that, it happens. What did I do? I made a mistake. Okay, I put the y coordinate in for x rather than putting it in for y. So let's fix that. So 5 times 17/14 equals negative x plus 2. So let's see, 50, but that'll give me 85/14 equals the opposite of x plus 2. Okay, so I have to take this and subtract 2. So I get negative x equals 85/14 minus 2. So as a mixed number, okay, I'm going to get 4 and 1/14, but that's negative x equals that. So x would equal negative 4 and 1/14. Okay, now I'm going to go back and check this guy. I'm not going to check every single one of them, but I'm going to go back and check this guy. Okay, so we have our check, and mainly because I made a mistake, so I want to make sure that I got it right. Okay, so here we go. We got 17/14 equals negative 3 times negative 4 and 1/14 minus 11. And let's see what happens here. If I compute that right-hand side, do I get 17/14? Okay, so we get negative 3 times negative 4 and 1/14, and then subtract 11. And I get 1 3/14, which is the same as 17/14. Okay, so it works in the first one. Let's check the second one. Okay, so I would have 5 times 17/14 equals the opposite of negative 4 and 1/14 plus 2. So let's see the right-hand side. This would cancel each other off, so I'd have 4 and 1/14 plus 2, so that's 6 and 1/14. And then let's see, when I take this guy and multiply by 5, let's see what I get. 5 times 17/14, and I get 6 and 1/14. Okay, so we should feel pretty good about that. Okay, so we're okay there. Let's try a couple more of those guys. Okay. Well, these are good to look at because these have fractions, and I told you if they had fractions, I'd get rid of the fractions first. Okay, so this top one, I got to get rid of the fraction. So how do you get rid of that 3/4? You take the least common denominator for all the fractions involved and you multiply through by it. So obviously there's only one fraction, so all I got to do is multiply everything by 4. Okay, so what happens after I get that guy? That'll be 4y equals 3x plus 20. And then this guy, I don't have any fractions, so I don't have to get rid of him. Okay, so let's see. I want to put this in standard form, so we just take that, move it over, change its sign. So I'm going to get a negative 3x plus 4y equals 20. All right, and that's in standard form. And then down here, I don't have to get rid of any fractions. I just got to move the 2y over. So when I move it over, it changes sign. So you get x minus 2y equals negative 3. And so I get this guy. Okay? All right, so notice I could multiply the bottom one by 3 and then add it up, and so the x's will cancel each other out. Or I could multiply the bottom one by 2 and add up, and the y's will cancel each other out. So it doesn't really make any difference. I'm going to multiply the bottom one by 2. Okay, so I don't do anything to the top one. And I multiply the bottom one by 2, so I get a 2x minus 4y equals negative 6. And then I add straight down. So that'll give me a negative x, these go away, equals 14. So x equals negative 14. Okay, so in my solution, okay, it looks like my x coordinate is negative 14. So I've got to find my y coordinate. So you could go to either one, okay? I think I'm going to do the bottom one, okay? So I take the negative 14, substitute in for x, equals 2y minus 3. Add 3 to both sides, so I get a negative 11 equals 2y, and then divide both sides by 2, so I get y equals negative 11 halves. And if you wanted to write that as negative 5 and a half, you could do that. Okay, it doesn't make any difference. Okay, negative 11 halves. Okay, and then you would just have to check. Okay, check to make sure this guy works in here and make sure this guy works in here. Okay, so I'll leave that up to you. You can check it if you want. Okay, we'll do one more of these. Okay, so let's see. I've got to get rid of the fractions here, so I got to multiply through by 3. And I get rid of the fractions here, so I got to multiply by 4. So let's see, when I multiply the top one by 3, I get 3y equals negative 2x minus 12. Okay. And then when I multiply by 4 here, I'm going to get 4y equals 1x, or just x, plus 28. Okay, so let's see, 3y equals negative 2x minus 12, good. 4y equals 1x plus 28, good. So I got rid of the fractions in both of them, so just move the term with x over, so change its sign, so I get 2x plus 3y equals negative 12. Okay, so there's one of my equations. And then here I would take the x and move it over, so it becomes negative x plus the 4y equals 28. And there's my other equation. So they're both in standard form. Okay, so that's the system I got to solve. 2x plus 3y equals negative 12, and negative x plus 4y equals 28. I got to solve that guy. All right, so clearly, I think it should be obvious to everybody, multiply the bottom one by 2. Then this will be a negative 2x, and when I add them with the first one, the x's cancel off. So I don't do anything to that first equation. That guy just stays the same. Multiply the bottom one by 2, so I get a negative 2x. I get a 8y, and I get a 56. And then we add straight down. So the x's cancel each other off. I get 11y here, and I'm going to get what? 44 right there. Okay, so dividing by 11, y gives me 4. So I know in my solution, my y coordinate is 4. Okay, so I got to go back. I could go, I could go to this form of the equation. I could go that form of the equation, or I could go to this guy or that guy. It doesn't make any difference. Okay, I just got to go back and substitute 4 in for y and solve. So I'm going to take this guy. I'm going to use that guy. Okay, so I go y equals 1/4 x plus 7. Put the 4 in for y, so I get 4 equals 1/4 x plus 7. Subtract 7 from both sides, so I get a negative 3 equals 1/4 x. Divide by 1/4 or multiply through by 4, doesn't make any difference, and I get x equals negative 12. So my x-coordinate has to be negative 12. Okay. Always love seeing the fractions. Okay, so this stuff should all be completely reviewed. For some reason, I don't have kids that normally come to me. They're not used to seeing that standard form unless they had me for geometry, where I did teach you that in geometry. But we still have some deficits working with linear algebra in general in high school. So hopefully we get all that stuff squared away this year.